acne. We all have it, 85% of us to be exact. We're so obsessed with it that it's become a $4.9 billion industry, and it's only growing. Thousands of products are on the market to help us combat it, and they all seem to share the same main ingredient, salicylic acid. We're all told that it's the saving grace for clear skin, but what exactly is this miracle drug, and what is it doing?
Salicylic acid is a white crystalline solid that was first prepared in 1838 from salicylaldehyde, a chemical found naturally in plants such as willows and wintergreens. Because of this, the name salicylic acid is derived from the Latin word for willow tree, which is salix. Okay, so let's introduce you to the general structure of this miracle chemical. Salicylic acid is a type of hydroxy acid, which means that it contains its signature carboxyl group and hydroxyl group. The benzene ring is a 6-carbon ring with double bonds. This provides salicylic acid with a sunscreen effect as the benzene ring transforms ultraviolet radiation into longer wave radiation, which is harmlessly emitted from the skin as heat. The nonpolar benzene ring also gives salicylic acid its lipophilic properties, allowing it to combat the evil oils of acne. The ortho position of the hydroxyl group is what identifies salicylic acid as salicylic acid. An ortho position is when there are two adjacent positions on a benzene ring. This functional group makes salicylic acid slightly polar, which allows it to be easily dissolved by polar alcohols, yet simultaneously poorly dissolved in water.
Today, salicylic acid is commercially produced in labs through the Kolbe-Schmidt process. As an overall reaction, we start out with phenol, which when combined with sodium hydroxide, produces sodium phenoxide. Then, sodium phenoxide is treated with gaseous carbon dioxide under high pressure, producing sodium salicylate. Lastly, the sodium salicylate is treated with a strong acid, and in this case, the acid will be sulfuric acid. And finally, there is formation of an aromatic hydroxy acid known as sodium salicylate. Now, let's look more closely at the reaction mechanism of sodium phenoxide forming into sodium salicylate. Gaseous carbon dioxide is reacted with sodium phenoxide, and here, carbon dioxide acts as an electrophile. An electrophile is a positively charged or neutral species having vacant electron orbitals that are attracted to an electron-rich center. Because of the introduction of the electrophile, delocalization of electrons takes place as follows on the sodium phenoxide molecule. Thus, the phenoxide ion will change into a carbonyl group. The attack of carbon dioxide at the ortho position will result in the loss of aromaticity in the ring, which means loss of double bond in the ring. But the deprotonation by base results in the regeneration of aromaticity of the ring and the loss of the temporary carbonyl group. The resulting sodium salicylate is treated with sulfuric acid, forming salicylic acid.
Now let's address the drug interaction in acne. How does it work? To understand the formation of acne, you need to know how your skin works. The pores in your skin contain oil glands. When you hit puberty, there's an increase in sex hormones called androgens. The excess hormones cause your oil glands to become overactive, enlarge, and produce too much oil or sebum. Sebum is produced in the sebaceous gland to lubricate your hair follicles. This is oil rich in keratin, water, lipids, and a bacteria called Propionibacterium acne. Acne pathogenesis starts due to the hypertrophy of the sebaceous gland. The next phase is when there is a hyperkeratinization of epithelial cells in the dermis, clogging the follicle with dead skin cells, resulting in the formation of a comedoe, which is essentially the pimple. This Komodo contains the oily sebum and bacteria and fatty acids, as well as their keratinized cells. What you know as a whitehead is a closed Komodo, while a blackhead is an open Komodo. The pores in your skin are great environments for bacterial growth. In the presence of sebum, the bacteria Propionibacterium acnes proliferates and feeds on the triglycerides, catalyzing them into free fatty acids. Eventually, the Komodo ruptures due to the buildup of pressure of the sebum.
Salicylic acid is used topically for its bacteriostatic, fungicidal, photoprotective, and keratolytic properties, meaning it protects against the sun, slows down the growth of bacteria and fungi, and also reduces the rate of keratinocyte production. Salicylic acid acts at the level of RNA transcription to downregulate the production of fibrinogen, fibronectin, and alpha hemolysin virulence factors necessary for bacterial replication in host tissues.
Salicylic acid's antibacterial properties works hand in hand with its anti-inflammatory effects. As mentioned before, the Komodo forms as a result of the overproduction of sebum, which encourages bacterial growth. In order to combat this infection, our immune response triggers the accumulation of white blood cells, as well as an increased blood flow to the target area, resulting in the inflamed Komodo. Salicylic acid also directly solubilizes the stratum corneum, which is the outer layer of the skin, by dissolving the intercellular cement. This process is what gradually eliminates squams or dead skin tissue from the stratum corneum.
Now we know what you must be thinking. Why is salicylic acid considered the best chemical for combating mild acne? There are many ingredients which the skincare industry tries to market to you. Benzoyl peroxide, glycolic acid, lactic acid, alpha hydroxy acids, and countless others. Most of them fall under the category of hydroxy acids, an organic acid with at least one carboxyl. Glycolic acid and lactic acid are categorized as alpha hydroxy acids. Alpha hydroxy acids are water soluble and can eat the bond between the dead skin layer and the younger, healthier skin. They consist of a carboxylic acid substituted with a hydroxyl group on the adjacent carbon. As they are water soluble, they are unable to penetrate lipids, and the oils of acne and are mostly used to target wrinkles and dry, dull skin. Additionally, lactic acid is a large molecule that cannot penetrate the dermis and can only concentrate on revitalizing the surface. Oppositely, salicylic acid is a beta-hydroxy acid which works both on the surface and inside the pore. Beta-hydroxy acids are composed of a carboxylic acid functional group, and the hydroxyl functional group is separated by two carbon atoms. Beta-hydroxy acids are also oil soluble, very small and lipophilic, which allows them to penetrate through oil. That being, salicylic acid is recommended if you have oily, acne-prone skin. Benzoyl peroxide, although a common acne treatment, is much harsher than salicylic acid. As it's commonly used in larger concentrations to bleach hair and whiten teeth, it tends to dry and irritate skin easier than other treatments. This is due to its high reactivity, which is because of the weak bond between the oxygen atoms being broken when coming into contact with the water in the skin.
Even though salicylic acid is among the highest ranked acne treatments, almost everything is bad in large doses. When a person's blood concentration of salicylic acid exceeds 35 milligrams per deciliter, they could potentially be diagnosed with salicylism or salicylic acid toxicity. To put things into perspective, applying 16 grams of lotion containing salicylic acid twice a day over a long period of time could result in some major side effects, including psychosis and coma induction. However, there have only been approximately 25 reported cases of salicylism since 1966, and the most common side effects are things like skin irritation and dizziness. Regardless, salicylic acid remains one of the highest ranked acne treatments due to it being insoluble and less harsh than some other medications.
Due to its functional groups, salicylic acid is best suited to combat our pesky acne. But not only is this miracle drug synthesized for our skin, it's also an active ingredient in many other things such as sunscreen, food preservatives, and even aspirin. All of this just from one discovery.